Hello again. I hope you're enjoying the weekend, as always. And this time, this is my sixth stream. Hopefully today I'm gonna finish the PageRank series, at least the basic one. And basically my idea today is to cover basic stuff from the multi-threaded perspective. That's a much better word than parallel in general. So that should what we should use. As always, post your questions in the chat. I'll try to answer them as fast as I can. And any suggestions if you have them, and also hit the subscribe if this type of content is useful to you. This today we're gonna probably be pretty quick since I've managed to prepare a bit everything. So basically, between half an hour and an hour it will take to finish. So let's get started. I can switch to my code view. At the beginning, I'll just go and load the basic implementation. I mean the multi-thread implementation of PageRank, and then run PageRank algorithm on the simple example first, and then we'll play with bigger and more scalable, bigger datasets. Let's and I'm doing these things inside the Mage repository. That's open source repository available on GitHub. And there is still a pull request that will add the PageRank algorithm, and I have just fixed an error from the last time. It was like a wrong calculation on the PageRank part, and let me just run all of that in the first place, and then import basic stuff. This is just as last time we did the debugging and compiling. So here we debug with GCC 8, since that's the default option on the Debian 10 inside the Docker container that Memgraph is running on. And we'll just rerun make, but I've already built the module. So let's go here and load the PageRank module. So this is all from the last let me jump here. This is all from the last live stream, so the command and everything. So I just use this for now, and let's start the module. So PageRank is now loaded, and as always I'll use Memgraph Lab to showcase stuff. This time I am actually working on version 1.3, which is ready and will be published soon, but it's not yet. I'm just using it here because it's a little bit more convenient, since as you can see here, we added these example datasets, and there are a bunch of them. So it's now super easy to load these example datasets and play around. It's much easier than it was before. Before they came within Memgraph, but yeah, that was kind of hard to switch between them. Okay, I have the dataset here, so I've just loaded the basic dataset. Let's just see what's the graph how the graph looks like. So here we have these 4 nodes, and yeah, basically PageRank C has the page C has the biggest rank, and I believe page A is the second one, and then page D has the lowest one. So yeah, let me run. So this query here is the actual multi-threaded implementation of PageRank now that should return the valid results now. If I run this and go under the data tab, these results now should be valid. They should be the same or very similar to the ones that we run with a single-threaded implementation. Yeah, I'll now go and explain the implementation a bit. I mean, just the high-level, most important details, and then we'll jump back and run a benchmark. Very simple one, but still we'll measure some time. Okay, so let's go in the actual code. We'll ignore so the module file is a bit bigger, but here we have the mapping between the graph stored in Memgraph and the graph loaded in the module. So it has the mappings, and there is also 2 versions of PageRank, one with subgraphs, but I won't go into details now about that. And basically here we run the parallel implementation, and here we just return the results. So this file here is now pretty much not important. So the most important stuff is here, and if we go parallel page, so here we have the actual implementation. So in the beginning we just take however many threads on this machine is, and so the idea is to let's say split all the edges into blocks and assign each block to a thread in order to and that thread then will process and calculate the PageRank. And this function here is just figuring out what should be the blocks. So how to assign all the edges, like array of edges, to a particular thread. And this is more or less standard. So we have a vector of ranks, and then the standard flags, like so that we continue iterations, and a flag that checks if we should continue iterations. Basically, since PageRank is an iterative algorithm, in each iteration, algorithm checks is there a converged solution. So if nothing much changed since the last iteration, the algorithm will stop calculating these ranks. And here we have this is a little bit C++ specific. So here we have these futures. Basically, that will just specify that we'll calculate PageRanks for that block of edges at some point in the future. And yeah, the vector of these futures, each future will have data at some point in time. And since cluster ID is just ID of that block where the edges are stored, and yeah, before we prepared all these, or we built like the list of all edges, and that's also pre-computed. So that list is available for the algorithm to upfront, and yeah, it's just used to calculate stuff. Here, for each block, we just assign basically a thread to that block in order to calculate these ranks. And if we jump here in this function, so this function is executed on a special thread. So there are multiple. It depends how many edges we have. So basically, if we, let's say on this machine, I have 12 threads, and the 12 threads will get these blocks. So let's say if there are 20k edges, each thread will get 1k edges to process. And here we just take these, let's say, borders we take a sub range of edges, and then for each edge there is source and target node, and we fetch these two IDs here, and then here the new rank vector is actually used to store these ratios between PageRank and the outgoing edges. So a PageRank for a certain node is calculated by a sum of all PageRank nodes that are coming in, that are pointing to that node, divided by the number of outgoing edges for that node that points to the node for which we are calculating a PageRank. And since we are iterating through the edges here, we initialize the whole vector first to 0, and then for each edge we update. Here the source and target, it's a bit tricky. I spent some time figuring out that, but source and target nodes are a bit tricky here. So there has to be a programmer has to be careful about which one to pick. So here basically for each edge we just add its contribution to the PageRank of a node, of a certain node, and new rank is that new rank source is a PageRank part of that particular node. And yeah, this thread here is super basic, so it just iterates through the block and adds these parts of the final PageRank to that new rank vector. So new rank vector actually can be the same size as can have the same size as the number of nodes, and basically that's it. It will just be like whatever nodes appears in that vector in that block, these PageRanks will be updated here, and that can be completely actually only this part here is parallel. So each thread has its own vector of ranks, and then each thread calculates them completely in a completely parallel way. They just share the old rank vector, but that's a read-only operation, so it's not a big deal, since the thread only reads data from this from this memory location. Okay, and then once each thread process that block, each block is then assigned to a final score. So in this function here, rank next is the final vector for all node ranks in that particular step. And here we just again we have initialization of that rank next vector. Later I'll talk about optimization. So these initializations here could be removed and should be removed and moved on an upper layer because they actually produce problems here, but I'll explain that later. And basically it's easy here. So all these for a given node, these let's say partial PageRank scores. So PageRank divided by number of outgoing edges has to be multiplied by the dumping factor and then added to the final PageRank score. And that's basically it. So everything else is more or less the same. So at the end, we are just finish with adding with initialization. For example, some nodes might not have any connections, and then they have default score and stuff like that. And here we check for the stopping criteria, but that's more or less irrelevant. That's the same as in the serial implementation, even though that also could be parallelized and make that concurrent. But yeah, the gain of that might be questionable in general. Okay, let's now go into the lab to load that dataset, to load some bigger dataset first. So I'll use here we still have relatively small datasets, but yeah, this one has let's say a decent number of edges. So I'll try to load this one. Yes. So this should now import the dataset. That will take some time, but it shouldn't be too long. Something doesn't work again. Do I have some error? Nope. Maybe I'm not connected or something. Yeah, it might happen. Usually it might happen that when Memgraph instance is restarted, then lab loses connection, then it has to be reconnected. Okay, dataset is loaded now, and yeah, we can just check how does it look like. I'll copy this query since it's huge, so limit 100. We have here some nice visualization. I've actually, these are some geospatial coordinates here, so lab can visualize them, which is super useful. I actually haven't planned this, so this is nice. But yeah, basically that's the dataset, and I'll just use MG console to calculate PageRank just because to get the exact time of the execution. So that's single threaded PageRank. So this is the one that we want, and I'll just limit the number of results to 10, just to ignore like the sending data back from the server. Still, the PageRank will execute exactly the same number of instructions, because PageRank is a global algorithm, and it has to process the entire graph in order to return some results. It can be, even though that's also possible, but it can't be easily like split into parts. It has to process like the entire graph. Okay, let's run this. So the whole algorithm took 10 seconds, which is amazing, and it has slight variations. Yeah, it has a bit more, but yeah, more or less 10 milliseconds is the execution time. Okay, we have now the ranks here, and I'll just try to run the single-threaded algorithm for the comparison of the whole thing. So let me go back here. So 2 weeks before, we had this example, which is super simple, single-threaded implementation. And I'll just make sure that this is compiled. Yeah, good. And then I go back here and rerun the example. So let me go. This is the query module, and this is the command. This is the command to run the single-threaded example, and I'll run this. Let's go back to lab, just to do this and rerun this again, since we restarted server. Okay, that's done now. We have the dataset here, and let's go back here. We have to reconnect, and let's call this. So we have the 8 milliseconds now, which is actually a bit less than the multi-thread implementation, and yeah, that's interesting, because it might not be the case that that these multi-thread arguments are multi-thread algorithms are faster, since there is a bunch of overhead. So I'll just go and fix that a bit. So let me now go here. Actually, I got some different results before, but yeah. So if you go here, more or less results are similar, but there could be a bunch of stuff why the results are the same. And actually, this is a fairly small graph, so we have to be careful while implementing and while optimizing the whole thing, to avoid anything that might produce these threads to be super slow. And that might be a bunch of stuff. So maybe the calculation is expensive. Maybe there is some memory allocations that make a thread slow. And also, if one thread is super slow, then basically the gains from the concurrent parallel execution could be super small, or even not gains at all, since there is a well-known let's say theorem. It's called Amdahl's law, where each like parallel execution is limited by the, let's say, slowest thread, and that slowest execution. And in this particular implementation, we are doing these strange things here. So this here is like initializing ranks in the middle of calculations. So that will cause problems because a new rank is a vector and it will get resized dynamically, and like during execution that vector will be moved through the memory, which is not great. In order to avoid that, this could be pre-calculated. So instead of having the new rank here uninitialized, it can be initialized like this. So that will now initialize the whole rank vector at once, and then not move it at all in the future. So we can completely remove this part here since it's not required at all. That's first optimization we can do. And also here, so this is not required at all. So because that vector can be like initialized only once. But yeah, this has marginal gains. It depends on the actual size. So I'll try to load bigger example as well, and then we'll hopefully see some gains. Even though we are playing now here with relatively small datasets, and then these gains are not evident. I mean, not super visible. So okay, that's that, and we can also, so this function is called here, so we have to initialize the rank here as well. Okay, and I think we good here. Rank. Okay. That's it for now. I think we good. Let's go and compile this. If we load this again, it should now. My bad. I've loaded the old version. I have to. I mean the single-threaded one. So here I've loaded the actual parallel module. Let's go back here. Datasets. Load the export trades dataset. This should be imported fairly quickly. Here we can see the queries that gets executed, and let's go back here. MG console. So yeah, last time I ran this, I had a couple of. So yeah, this is now. Yeah, very similar. Very similar, maybe a bit faster, since it has, yeah. But yeah, the vector of nodes is fairly small. So let's try and run a little bit bigger dataset. So what else we have? TED Talks. Maybe this one. This one has a bunch of edges. So confirm. That will take a little bit more time. I think, yeah, it's importing. Since this is importing now, feel free to ask any questions. Yeah. So I know, maybe I can explain. So why I could preload all these datasets, but the problem is that snapshot is a little bit more optimized when it's loaded into memory, and then like these algorithms would have like different starting points, or like I'm doing like most regular, like the most standard import procedure. So that's how usually the dataset should be loaded. So it's most representative, let's say. Maybe this view here is a bit more relevant. Yeah, we are on the half of the edges, so it will be loaded soon. Almost there, almost there. I'm actually a bit, while it is loading, I'm actually a bit unsure what we're gonna do next time. So if you have any suggestions, feel free to suggest. Done. Great. And let me go back here. So we have that parallel PageRank. So if we run this, great. So this time dataset, so the algorithm took 200 milliseconds. So it has like half a million edges. If we rerun again, so it's like around 200 milliseconds, more or less, a bit less than that, which is great. And then let's try do single threaded. Let's go back here. I have to rerun. Single threaded is here, so I have to start again. Let me check. Yeah, this is okay. Again, we're gonna have to wait a couple of I clicked wrong dataset. Sorry. I have to load this one. Yeah, I saw 2 concurrent viewers. Yeah, feel free. This will take a couple of seconds, up to a minute. So feel free to ask something. It would be great if these live streams would be like interactive, and if I might see people, but yeah, it's a bit strange like this. Maybe I can actually explore if I click here. That will take some time. What we have in this data set. So we have a hero. Then we have appeared in comic. And then is part of series. Comic series. So that's the... and hero is... We don't see how to... yeah. Hero is attached to hero. I think this is like some kind of interaction between heroes, probably a fight or something like that, since it's Marvel. What else we have? history favorite. Yeah, I have these index queries here, but that's fine. Let's wait a bit and then we're good. And yeah, while this is imported here, I can also, I forgot to mention here. So this is again, even though this is more scalable already, I mean, we'll see now, but this is again not super optimal implementation. So we could have like a thread pool, and that would probably improve some stuff. And also these small things at the end could be parallelized as well, and then that would probably be much better than it is now. But still, yeah, we're done. So now we have the dataset loaded, and let's get back here. If we go back here, actually here, so we have to rerun. Now this shouldn't work because it's not the same. This should work. So this should be the single threaded implementation. So if you remember last time, so this is the time from multi-thread execution. If we run this is now again faster. Yeah, I got different times in the past. Yeah, but it's very close. So still we have some overhead of the execution. But when I run this previously, I got like 500 milliseconds instead of 200. Interesting. Yeah, it's more stable than the parallel implementation. Interesting. All right. What to say? I have to spend more time on optimizing stuff. But yeah, probably I should load a much bigger dataset, and then it would be obvious. But yeah, at least we have the valid implementation now, and it should be optimized further. At some point, there should be a gain from running these multi-threaded scenarios. Okay. Let me swap. So here I am again. That's it for that I had for today. Still no questions, so we good on that end. Next time, I'm not sure what I'm gonna do. Probably I'll try to experiment with Rust query modules. I don't have any I don't have much experience with Rust. I'm complete noob there. But I'll try to build a Rust query module, probably in a couple of Saturdays, not in just one, since it's not a trivial task. That's one. Here I think we are good with PageRank in general. We have the parallel implementation, multi-thread implementation. But yeah, it has to be improved further, and we'll probably improve it further, and that will be part of the Mage repository. And yeah, then it would be able to, everyone will be able to run that and leverage that, leverage the PageRank implementation, which is in the Mage. And yeah, that's it for today. Have a nice rest of the of the weekend. Please like, share, subscribe if this is interesting to you, and yeah, see you next time. Thank you. Bye bye.